This call is now being recorded.
Okay, that is solve the initial value problem by using the Laplace transforms. I told you why it is called initial value problem, that is IVP, because of these given conditions, this problem is called initial value problem. If these conditions are not given, simply you can treat this as a linear differential equation of second order. Then you can find CF and PI with respect to this CF you can find, with respect to this you can find PI, then you can write. But if these conditions are given, initial value problem, it becomes initial value problems, then you can use that normal method also, and you can use for betterment or for to get the answer very quickly without getting without trying to get CF and PI. Directly you can use Laplace transform to this, then you can solve it. Okay, now as usual what we told, as in case of previous examples, first we have to write down this part. First we have to write down this part in the form y double dash of t, that is d square over by dt square, means y double dash of t plus 4 into y dash of t, then plus 4 times y of t is equal to plus 4 times y of t is equal to, you can write this one as a, e to the power t. Now after writing this in this format, what we have to do, we have to apply Laplace transform to this. We have to apply Laplace transform to this L of y double dash of t plus 4 into y dash of t plus 4 into y of t, whatever it is there, you can write. Then this is equal to, here it is not 0. If it is 0, you would have kept this as it is. So this part also, for this part also in terms of t, so for this also you need to apply Laplace. So we applied here Laplace transform of e to the power minus t. Therefore what happens, L of y double dash of t plus 4 into L of y of t. Okay, because this Laplace operator is linear operator, we can operate it term by term. 4 into L of y of t, then this is, then 4 into L of y of t is equal to, you already know Laplace transform of e raised to minus t is 1 divided by s plus 1. You can write in this format. Then next, write the expression for this. What is the expression for this? S square into L of y of t minus s into y at 0 minus y dash at 0. Then plus 4, write the expression for this. Expression for this is s into L of y of t minus y at 0 plus this is the standard form, so you keep that as it is, because we need to find the value of y here, y of t here. Okay, so this part 1 divided by s plus 1, you keep that as it is. Now we are given with the value of y dash at 0, y dash at 0. So substitute those values, these values. Y at t is equal to 0 is 0, y dash at t is equal to 0 here. So what you will get, this remains s square into L of y of t. This s into 0, it becomes 0, we have written 0 here. Then y dash of 0, that becomes 0, we have written 0 here. Then take this 4 inside. If you take this 4 inside, you will get 4s into L of y of t. Then this 4 into y of 0 you will get, anyway y of 0 is 0, so we have written here plus into minus, it is 0, you have written plus 4 into L of y of t, you have kept that as it is. This part here it is as usual. Okay, 1 divided by s plus 1, keep that as it is. Now observe this term, observe this term. From these all these terms, let us take L of y of t common. If you take L of y of t common, from the first term you left with the s square, from this term you left with the s, from this term you left with the 4. Okay, so if you take L of y of t common, you left with the s square plus 4s plus 4 into L of y of t is equal to, you will get 1 divided by s plus 1. But this s square plus 4s plus 4, it is of the form a square plus 2ab plus b square form. So you can write this complete thing as s plus 2 whole square here, because a is equal to, you will get 2. Okay, s plus 2 whole square into L of y of t is equal to 1 divided by s plus 1. What this is a simplified form of after substituting initial values and expressing this writing expression for Laplace transforms of y dash y double dash, putting the values after simplification you will get there. But we don't want this. We want a solution for y. So what we will do, first thing, we will transfer this s plus 1 s plus 2 whole square to this side. So this becomes L of y of t is equal to 1 divided by s plus 1 into s plus 2 whole square. Nothing to worry. But we don't want even L of y of t here. We don't want Laplace transform of this. We want what? A solution of this. So what we will do there? We want value of y which satisfies the given equation. So what you need to do? You take this Laplace operator this time. That becomes y of t is equal to L inverse of s 1 divided by s plus 1 into s plus 2 whole square. Now we have to solve this part, or we have to express this function of s in terms of t, so that you will get the solution for this by operating inverse. Okay, so Laplace inverse. So now once you go to the Laplace inverse, once you need to find solve this part. So what you need to do, you need to concentrate on the numerator and denominator. Here numerator is what here? 1. Denominator is a, in the denominator you are having two factors. In the denominator you are having two factors. So if you simplify this, you will get s cube. Numerator power is s raised to 0. So what happens? Numerator becomes 1. So it is a proper fraction. Since it is a proper fraction, what we should do, we should concentrate on what type of factors are these. What type of factors are these? These two are the, one factor is linear factor, another factor is a non-linear repeated factor. Non-linear repeated factor. So what we need to do, of course, factorization is possible here. You can write this one as s plus 2 into s plus 2. So three factors exist. One factor is repeated, another one is a non-repeated linear factor. This is non-linear factor. So with respect to that, you can consider this part and you can write this one as a 1 divided by, first you will resolve this proper fraction into partial fractions. So we'll consider that 1 divided by s plus 1 into s plus 2 whole square. This can be written as a divided by s plus 1 plus b divided by s plus 2 plus c divided by s plus 2 whole square. So once you write this, so what we need to do, as usual, we have to take the LCM in this part. If you take the LCM in this part, s plus 1 is already there. So what you have to do, out of these two, highest factor is s plus 2. So we have to multiply this with s plus 2. We'll multiply this with a with s plus 2 whole square. Okay, so it becomes 1 is equal to s plus 2 whole square plus b into, you have to multiply this with 1 s plus 1 and 1 s plus 2. So it becomes b into s plus 1 into s plus 2 plus c into, you are already having s plus 1 s plus 2 whole square here, I'm sorry. So you have to multiply this c with s plus 1. You have to multiply that c with s plus 1. Once you take the LCM here, it will be of the form s plus 1 into s plus 2 whole square. So this term LCM and this LCM get cancelled. So you'll get finally this equation. Okay, once you got this equation, what you need to do, you need to get the value of a b c. Here there are different techniques. So first we will find to find the value of a, we'll check is it possible to make these two zeros or what. If that is a so in such cases, what you have to do, you have to use the comparing the corresponding coefficients method, or you can use see, you can get direct value of s here, because you will find one common factor here. What is that? S plus 1. So to get the value, s plus 1 is not here, so we can make a coefficient of b 0 very easily, coefficient of c 0 very easily. So what we need to do is we need to put the value of s properly to make this factor 0 and to make this factor 0. For that purpose, what we will do, in the above equation you will put s is equal to minus 1. If you put s is equal to minus 1, this becomes 0 directly, then this becomes 0 directly. So this entire terms will become 0. Here you left with 1 is equal to a into minus 1 plus 2 whole square. This is 0, this is 0, I have written here. So 1 is equal to a into, this is see, 1 minus, actually this is plus, minus 1 plus 2 whole square, it becomes plus 1 whole square. Plus 1 whole square means also, whether it is plus or minus, don't worry, but it is according to this, here it is plus 1 whole square means it becomes a 1. So a is equal to, you will get this value as 1. Once you got a is equal to 1, now we will check is it possible to get the value of b directly. Is it possible to get the value of b directly? If not possible, we will not we will concentrate on c. If not possible, we will go to the comparing the coefficients method. Okay, so here this term contains s plus 2, this term also contains s plus 2, so this term is not containing s plus 2. So it's not possible to find the value of b directly here, but it is possible to find the value of c directly. So what we will do, to get the value of c, we will try to make this 0, this 0. Is it possible to make this 0? Not possible, no? Hope not possible, I'm sorry, because square is there. If you put s is equal to 2 also, minus 2 or plus 2 also, this becomes minus 2 means let me check. Okay, minus 2 is possible, I'm sorry, minus 2 is possible here. So if you put s is equal to minus 2, this becomes minus 2 minus 2 0, then this is minus 2 minus 2, this is 0. So this factor becomes 0, this factor becomes 0. So this becomes what? C into minus 2 plus 1 means it becomes minus 1. So making this, getting the value of c directly, it is a possible here. So what we will do, let us put s is equal to minus 2. If you put s is equal to minus 2, LHS side it is 1, keep that as it is. So a coefficient becomes 0, so it is directly 0. B coefficient becomes 0, so this term becomes directly 0. So then this is c into minus 2 plus 1. Minus 2 plus 1 means it becomes this is, this term becomes c into, you will get there minus 1, which is 1 is equal to minus c, you will get, excuse me, 1 is equal to minus c, you will get, if you will get 1 is equal to minus c, so c value will become what? We don't want minus c value, we want c value. C value will be minus 1. Now you got a value as 1 and and one minute, you got a value as minus 1 and sorry, a value as 1, c value as minus 1. So now what we have to do, we will put those values here. Okay, I'm sorry, we'll put s is equal to 0, we will put s is equal to 0 in this this equation. Where is that? Just 1 minute. We'll put s is equal to 0 in this equation. 1 minute. We'll put s is equal to 0 in this equation. You can try this, or you can go for comparing the corresponding coefficient which I told earlier. So what you do, put s is equal to 0, you will get this equation. So once you got this equation, so you transfer these already you know the value of a here. Put a is equal to 1, c is equal to minus 1. So 1 is equal to 4 plus 2b minus 1. So this becomes 4 minus 1 is 3. Take that to this side, that becomes 1 minus 3 is equal to this 2b, you keep as it is. So you will get minus 2 is equal to minus 2 is equal to 2b. Therefore this 2 get cancels, you will get b is equal to minus 1. So once you got those values, so what you need to do, you have to substitute those a b c values, in this equation 1. So let us put a b c values in equation. So that becomes 1 divided by s plus 1 minus 1 divided by s plus 2, because b value is minus 1, minus c 1 divided by s plus 2 whole square. So this becomes this is s plus 2. Okay, because it c value is also minus 1, so I have written here. Now therefore L inverse of 1 divided by s plus 1 into s plus 2 whole square becomes L inverse of 1 divided by s plus 1 minus 1 divided by s plus 2 minus 1 divided by s plus 2 whole square. So this is a linear operator. Operating this term by term to this, you will get L inverse of s plus 1 minus L inverse of s plus 2 minus L inverse of s plus 2 whole square. So you already know what is L inverse of 1 divided by s plus 1 is e to the power minus t, and minus as it is L inverse of minus 2t 1, sorry, L inverse of 1 divided by s plus 2 is e to the power minus 2t. Then you observe this, if it is only s plus 2, you would have written it directly. It is s plus 2 whole square, so in place of s square you have s plus 2 here. So using the reverse shifting property, take this 2 outside, wherever s is there you have s plus 2 there. So taking a 2 outside, what you will get, it becomes e to the power minus 2t into L inverse of 1 divided by s square. So L inverse of 1 divided by s square, how you are going to write? Using the formula L inverse of, I'm sorry, I write it as L inverse. L inverse of 1 divided by s plus 1 is this is t raised to n divided by n factorial. Here n is 2 means n plus 1 is 2 means L will become 1. So if you put t is equal to 1, sorry, n is equal to 1 here, you will get t raised to 1 divided by 1 factorial, which is t, which you have written here. Therefore, the required answer is what? E to the power minus t minus this is y of t is equal to, okay, this is y of t is equal to, or simply you can write y is equal to or y of t is equal to e to the power minus t minus e raised to minus 2t, e raised to minus 2t. From these two you have taken e raised to minus 2t common. From this you left with the minus of e raised to minus 2t you have taken common. So this becomes plus 1 plus t, you will get which is the required answer. Do you have any difficulty with this? Am I
No,
audible?
sir.
Am I audible clearly?
Yes, sir.
Okay. We will go to the next one more important example which has been asked in your examination, VTU examination, June 2007. That is using Laplace transforms technique, solve x double dash minus 2 into x dash plus x is equal to e to the power 2t with the initial conditions x at t is equal to 0 is 0, x dash at t is equal to 0 is minus 1. Means instead of taking y as a dependent variable, they are taking x as a dependent variable. So this means you have to solve this equation, d square x divided by dt square. Instead of y you are having x here, so you have to solve it for x, you have to solve it for x. Okay, this is a d square x divided by dt square, this is a dx by dt, this is simply x of t. Is that clear? Okay, next what we need to do, we have to write this in terms of standard form, that is x double as a function of t, I'm sorry, as a function of t, that is x double dash of t minus 2 into x dash of t plus x of t is equal to this e to the power 2t as it is. We'll think of this initial conditions later. Okay, now operate Laplace on this. If you operate Laplace on this, what you will get, L of x double dash of t minus 2 into L of x dash of t plus L into x of t. So Laplace operator is linear, so we operated it term by term separately. So L of 2t as it's both the sides you have to apply Laplace transforms. Next what happens, so write the expression for this. There it is y, in place of y you are having x, so you have to write that in terms of x only, that is s square into L of x of t. If it is y you would have written this one as y, if it is z you would have written it as a z, if it is some other variable you would have written this as a some other variable you have given in terms of x, so you will write this one as s square into L of x of t minus s into x at t is equal to 0 minus x dash at t is equal to 0 minus this 2 as it is here into bracket. So write the expression for this. If you write the sorry, 1 minute, I'll not make it jumbled. Okay, so write the expression for this, that is s into it becomes L of x of t minus x of 0. This term we keep that as it is. So Laplace transform of e to the power 2t is 1 divided by s minus 2, which we have to write. Then immediately after this step, what we will do, we will try to put the initial conditions, then we will simplify these things. Okay, we'll try to put the initial conditions. What are the initial conditions here? X at 0, x at t is equal to 0 is 0, x at t is equal to 0 is minus 1. You have to be little bit careful. We'll put that value here, here, and here, wherever it is applicable. So s square into L of x of t, then s into x of 0, x of 0 is 0, so you'll write that as a 0 minus 0. Then this is see, this you have written this one as a plus 1 because x dash at x is equal to sorry, at t is equal to 0 is minus 1, so it becomes minus of minus 1, so it is a plus 1 we have written here. So take this minus 2 inside, so this becomes a minus 2s into L of x of t. Then this is a minus into minus, actually minus into minus, this is plus this x of 0 is 0, so it becomes a 0 here. Next plus L of x of t as it is, L of x of t as it is, then 1 divided by is equal to 1 divided by s minus 2 also as it is. Now please, we'll go a little bit quick here. So concentrate on this example, concentrate on this part, concentrate on this term, not example, term. Okay, this term, this term, this term. Here L of x of t is common, so we'll take that L of x t, L of x of t common. So Laplace transform of f of t, if you take common from the first term, you will left with the s square. From the second term, you will left with the minus 2s. From the third term, it is only L of x of t. So you left with the 1. You can write there. And actually, apart from all these terms, after taking common L of x of t, so one term is there in the LHS which does not contain x of t, that is a plus 1. So plus 1 you would have left here. Then we have taken that plus 1 to this side. That becomes a minus 1, which we have written here. Don't get confused. Okay, which we have written there. Okay, then what happens? So next, before taking this term, this term can be written as s minus 1 whole square, because it is of the form a square minus 2ab plus b square type, which is of the form a minus b whole square form. A is equal to 1 here, so you can write this one as a s minus 1 whole square. Now here what we will do, here in this case we will take the LCM will be what? S minus 2. S minus 2, if you take the LCM, so what happens? It becomes 1 minus this is you will get there s minus 2. Make it as a one term, so that when you take this term to this side, it becomes easy for you. So therefore L of x of t, or if you simplify this, you will get take this minus sign inside, you will get minus s plus 2 minus s plus 2 plus 2 plus 1 is 3. 3 minus s you will get, or you can write this one as first you can write minus s plus 3, no issues. Okay, then this is s minus 1 whole square into L of x of t is equal to 3 minus s divided by s minus 2. S minus 2. Now taking this term to this side, so what happens? L of x of t is equal to, you will get 3 minus s divided by s minus 1 whole square to, then this is s minus 2. But we don't want this, we want solution for x. So take this operator L to this side, so that becomes x of t is equal to L inverse of 3 minus s divided by s minus 1 whole square into s minus 2. Now if you find the value of this, if you express this in terms of t, and by finding inverse of this, then you will get a expression for or solution of the given differential equation. Okay, so for that purpose, please concentrate here. In the numerator you are having s raised to 1, and if you simplify this, you will get this becomes s square, this becomes s, only power of s you need to call highest power of s. Okay, so it becomes s cube, because it becomes s square into s means you will get s cube. So this is a proper fraction. Once you decide it is a proper fraction, once you decide that it is a proper fraction, so what you need to do, you need to concentrate on the denominator. What type of factors are there? One is a linear factor, another one is a non-linear repeated factor. Am I right? Dear friends, am I right? Am I right?
Yes, sir.
Okay. Therefore, consider this term that 3 minus s divided by s minus 1 whole square to s minus 2. So, since because of this repeated factor, you can take the factors with respect to this as two constants. You will get a divided by s minus 1 plus divided by s minus 1 whole square plus c divided by linear factor s minus 2 we have taken. Now, after that, as usual, what you need to do? You need to take the LCM here. If you take the LCM, this part here you will get, you have to multiply, it is only s minus 1 there, so you have to multiply this by one more s minus 1 into s minus 2, that is a into s minus 1 into s minus 2 you will get, plus b into s minus 1 whole square is already there, so you have to multiply it with s minus 2 plus c into s minus 2 is already there, so you have to take this one as a s minus 2 whole, sorry, s minus 1 whole square. Okay, once you take the LCM, what happens? LHS is equal to RHS is there, so what happens? Denominator will be same. So after taking the LCM, this and this get cancels. You left with from this term LHS you left with 3 minus s, and from this term you left with a into s minus 1 to s minus 2 plus b into s minus 2 plus c into s minus 1 whole square. Okay, s minus 1 whole square. So then next what you have to do, by using this equation carefully, you have to get the value of a, b, c. Now check, is it possible to get the value of a directly? Here this contains s minus 1, this contains s minus 1. If you put s is equal to 1, you will get a b value directly, and this contains s minus 2, this contains s minus 2. If you put s is equal to 2, this becomes 0, this becomes 0, you will get the directly value of c. Here getting the value of a directly is not possible, so we need to we try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of a directly. So what we will do, we will try to get the value of
Friends, am I audible?
Yes, sir.
Okay. Sorry, because of this current network problem, I have been disconnected. Now I'll start again. Okay, just 1 minute. Okay. See here, friends, you will get this equation. So once you got this equation here, getting the value of a directly is not possible. So we try to get the value of b and c. Let us check afterwards. Getting b and c, you can very easily get the value of a there. Okay, we can very easily get the value of a. So for that purpose, what we will do, we will first just a minute. First we'll put s is equal to 1, so that we will get the value of b. Let us put s is equal to 1. If you put s is equal to 1, so this becomes 3 minus 1 into s is equal to 1 means this becomes 0. So this becomes 0 means this term will completely become 0. b into you will get 1 minus 2 plus c into s is equal to 1 means this also becomes 0. So you will get this 3 minus 1 is 2. You will get 1 minus b into 1 minus 2 means you will get b into minus 1. So we don't want minus b value here. So b is equal to, you will get minus 2. Now to get the value of c, now to get the value of c, what we will do, we will put some common factor is there in coefficient of a and coefficient of b, that is s minus 2 is there. Put s is equal to 2. If you put s is equal to 2, you will get 3 in 3 minus 2 is equal to a coefficient becomes 0, so this becomes 0. B coefficient becomes 0, so this term becomes 0. So c into you will get 2 minus 1 whole square, 2 minus 1 whole square, which will be what? 2 minus 1 is 1. 1 whole square means you will get this as 1. So this becomes c is equal to 1, because 3 minus 2 is 1. 1 is equal to c, you will get c is equal to 1. Once you get a and b, sorry, b and c value here, come back to this equation. So what we will do, we will try to get the value of a. For that purpose, what we will do, let us put s is equal to 0. If you put s is equal to 0, you will get 3 into 3, a into minus 1, because 0 into minus 0 minus 1, it becomes a into minus 1 into minus 2 plus b into, you will get a minus 2 plus c into, this becomes minus 1 whole square. So you can write this one as a into minus 1 minus 2 plus b into minus 2 plus c into minus 1 whole square. So this becomes 3 is equal to 2a minus 2b plus c, because minus into minus plus 2b, then it becomes minus 2b, then it's minus 1 whole square, means it becomes minus 1 whole square is 1, 1 into plus c is plus c. So you'll get a 3 is equal to 2a we have written here, plus 2b, sorry, plus 4 minus plus 1 we have written, because c value is 1 that you have written, b value is minus 2. If you put minus 2 or minus into minus, it becomes a plus. So 4 plus 1 is 5. So you take that 5 this side, it becomes a 3 minus 5 is equal to 2a. Therefore 3 minus 5 is minus 2a, sorry, minus 2 is equal to minus 2a. These two get cancelled, so you get a value as a minus 1. Now pick up those two values, those three values a, b, c, substitute in the equation whatever we have observed there. So you'll get minus 1 divided by s minus 1, minus 2 divided by s minus 2 whole square, plus 1 divided by s minus 2, because this is because a value is minus 1, b value is minus 2, c value is plus 1. So now, therefore we don't want this, okay, therefore L inverse of this one we want. So x of t is equal to, we'll write this, then we'll write this in the partial fractions type. Partial fractions, we'll express this in terms of partial fractions, that is L inverse of minus 1 divided by s minus 1, minus 2 divided by s minus 1 whole square, plus 1 divided by s minus 2 you will get. So you will get operating this L inverse separately on this, you will get minus of L inverse of 1 divided by s minus 1. Take this 2 outside, so it becomes minus 2 into L inverse of 1 divided by s minus 1 whole square, plus L inverse of 1 divided by s minus 2 you will get. So minus as it is, L inverse of s minus 1 becomes using standard result, it is e to the power t minus 2 as it is. So observe this, L inverse of, suppose if it is L inverse of, suppose if you are having only s minus 1, you would have written directly e to the power t, but it is s minus 1 whole square. So meaning of this is wherever it is actually 1 divided by s square root, wherever s is there you have replaced it by, wherever s is there you are replaced by s minus 1, uh, s minus 1. So that is using shifting property. So what we can write, using a reverse shifting property, what we can take, this 1 should be taken outside, so that becomes e to the power t, and you left with your L inverse of 1 divided by s square. This is plus L inverse of e to the, sorry, 1 divided by s minus 2 is e to the power 2t. So L inverse of s square, already you know what is that, that is L inverse of s square becomes t raised to 1 divided by 1 factorial, which can be written as t. So this is e to the power 2t as it is. So final answer is x of t is equal to minus e to the power minus t, minus e to the power minus t into, sorry, minus 2 times e raised to t into 2t, t into t, plus e to the power 2t. So from these two, these two are with the negative sign, so you can take e to the power minus t outside, minus of, not e to the power minus t, I'm sorry, minus of e raised to plus t you can take outside. So from this term you can write it as 1, from this term you have to the plus 2t, then e to the power 2t plus e to the power 2t. This is your final answer. So if you want, you can write this term first, then you can write this term. So this is the solution of the given differential equation by using Laplace transforms. Is that clear? Is that clear?
Yes, sir.
Okay, if it is clear, let me take one more example here. Let me take one more example. Just one second. Just one second. Is my screen is visible? My screen is visible?
Yes, sir.
Okay. See, we'll take one more example which has been asked in your VTU 2015 examination. So this is a very little bit easy example. Solve using the Laplace transforms. D square by dt square plus 2 times dy by dt plus y is equal to t into e to the power minus t minus t, with the initial conditions y at t is equal to 0 is 1, y dash at t is equal to, y dash at t is equal to 0 is minus 2. Okay, so as usual you have to write this. So here marking is not possible because it is not opening in that window. Okay, so directly I'll explain. Will it be okay? Will it be okay? Will it be okay? Am I audible clearly?
Sir, PPT is not visible, sir.
It's not visible. Okay, 1 minute. 1 minute. 1 minute. 1 minute. I'll try to share it once again. Just 1 minute. 1 minute. Now is it visible? Dear friends, now is it visible?
Yes,
Yes,
sir.
sir.
Okay. Take this. See, solve using Laplace transform method. Equation is d square by dt square plus 2 times dy by dt plus y is equal to t into e to the power minus t with the initial conditions. Y at t is equal to 0 is 1, y dash at t is equal to 0 is minus 2. So first you have to write this. Here marking is not possible. Please only for this example you cooperate because it is not opening in that format. Okay. So y double dash of t plus 2 into y dash of t plus y of t is equal to t into e to the power minus t we have written. So after apply Laplace transform, that becomes a L of y double dash of t 2 into L of y dash of t plus L of y of t is equal to Laplace transform of t e to the power minus t. See here you can use a shifting property as well as a second property effect of multiplication by t, but effect of multiplication by t you need to differentiate it. To avoid the more complications we will use a shifting property, so this side. Okay, so you need to remember that shifting property. So what we will do now, we will substitute the expression for this L of y double dash of t, that becomes a s square into L of y of t minus s into y at t is equal to 0 minus y dash at t is equal to 0. This expression for this is 1 plus 2 as it is. We will substitute expression for this, that is s into L of y of t minus y dash sorry y of 0 plus this L of y of t will keep as it is. Now concentrate on this, that is L into e to the power minus t into t. So for that purpose, what we need to do, according to the shifting property, first you have to write, first you have to find Laplace transform of except e to the power t. Whatever the term is there, that you treat as f of t. So Laplace transform of t becomes, what is Laplace transform of t here? Which formula you are going to use? T is a positive integer. That becomes yes, n factorial divided by s raised to n plus 1. So here t is equal to 1. So it becomes a 1 divided by s square, where s change into s plus 1 because of this e to the power minus t present here. So s change into s plus 1 we have written here. So this side you start putting the values. If you put the values, so what happens? After simplification you will get s square plus 2s plus 1 into L of y of t. So minus s plus 2 minus 2 you will get there. So these 2 plus 2 minus 2 will get cancelled. You will get you will be left with only minus 1 only. So this term becomes 1 divided by s plus 1 whole square. Am I right? So actually you need to put those values here. Okay, after that simplification you will get this part. Then immediately after this, what you need to do, take this s to this side. If you take this s to this side, it becomes what? 1 divided by s plus 1 whole square plus s. So this term is you can write this term as s plus 1 whole square into L of y of t. Now we'll keep this as it is, that is 1 divided by s plus 1 whole square plus s as it is. So we'll take this term to this side. So if you take this term to this side, it becomes what? L of y of t is equal to 1 divided by s plus 1 whole square into s plus 1 whole square. It becomes s plus s 1 raised to 4 plus you have to multiply this by this term, that is 1 divided by this term. So that s divided by s plus 1 whole square. We have not taken LCM here because if you take the LCM here, then afterwards again while you apply the inverse, it becomes a little bit complicated. So we kept this term as it is for our convenience. So here sum of two terms are there. So y of t is equal to, transfer this L to this side, it becomes L inverse of 1 divided by s plus 1, s plus 1 raised to 4 plus s divided by s plus 1 raised to 2. Okay, so therefore applying inverse transform separately to this, so you can write this in place of s you are having s plus 1 here. So s plus 1 raised to 4 means numerator is 1. So if it is only 1 divided by s plus 1, you would have used e to the power, you would have written this one as e to the power minus t, but it is s plus 1 raised to 4 there. So what you need to do, first reverse shifting property you have to apply. So it becomes e raised to minus t into L inverse of 1 divided by s raised to 4 plus here you observe numerator contains s, it is s plus 1 raised to 2, s plus 1 raised to 2. So what happens here, directly you can't use reverse shifting property. You have to express numerator, denominator is in the form s plus or minus a form. So numerator should be expressed in terms of s plus 1 because it is s plus 1 in the denominator there. So what you need to do, you have to add and subtract 1 to the numerator. So it can be written as a numerator in this part s plus 1 minus 1. So that if you simplify this, once again original thing we will get as it is. Next what you will get, so e to the power t as it is here, then this becomes L inverse of, I'm sorry this is written wrong here, L inverse of 1 divided by s raised to 4. L inverse of 1 divided by s raised to 4 becomes what here? Yes, this term L inverse of 1 divided by s raised to 4, it can be written as a t raised to L inverse of 1 divided by s raised to n plus 1 can be written as a s t raised to n divided by n factorial. It is writing mistake, don't worry. T raised to n divided by n factorial. Here n plus 1 is equal to, you are having 4, so n is equal to, you will get 3. N is equal to, you will get 3. So you will get s t cube divided, sorry, n fact, what you will get, t cube divided by yes, can anybody tell me there? T cube divided by 3 factorial you will get. T cube divided by 3 factorial means it becomes a, it is actually not a, this is a t cube divided by 3 factorial into e to the power t. It's not t square, it is t cube divided by 3 factorial. Then here in this part you observe, yes, in place of wherever s is there in this quantity f bar s, you are having a s plus 1. Take that s plus 1. So take, using reverse shifting property, you can write this one as a L inverse of e to the power minus t into L inverse of s plus 1. If you take this one, you will get s minus 1, actually it is s minus 1 divided by s square, you will get s minus 1 divided by s square. So what happens, this is, I'm sorry, make this answer correct. This is t cube into e raised to minus t divided by 6 plus e raised to t as it is. Taking this separately, taking this s square separated to the numerator, so you will get 1 divided by s, this is minus here, minus 1 divided by s square, this is not plus, this is minus 1 divided by s square you will get. So then what happens, this is a t cube into e to the power minus t cube into e to the power minus t e to the power minus t divided by 6 only. This is little bit writing confusion is there, this is 6 only, so it becomes 6. Then this is e raised to t minus t as it is. L inverse of 1 by s is 1, this is minus, this is not plus, this is minus L inverse of 1 divided by s square is t. This is your final answer. Hope this is clear. Make this see, while writing we would have used that some little bit in hurry we would have written that one, so please make that correction here. Okay, will you make that correction? Sure.
Yes, sir.
Okay, please make that correction. And with this we'll stop today's class. And with this, your some more examples are there, I will show you. Some more examples are there which has been asked very recently, important examples. I will send these notes to you, okay, in the Google Classroom. Please try to solve them. If you have any difficulties, you can ask me. Okay, will you ask me? Will you ask me?
Yes, sir.
Definitely.
Yes, sir.
Yes, sir.
Okay, now I will stop this. I will stop this. 1 second, you wait for 2 minutes.